Hello everyone, welcome to MindMatrix. So in this video, we will be solving questions of DBMS from GATE PYQ 2023. So this is the series that we have already started. We have covered so far three subjects: operating system, compiler design and digital logic. And today in this video, we will be solving questions from DBMS subject. So without waiting, let's start. So before starting, let me introduce myself. My name is Anshul Sharma. I'm upcoming software engineer at Juniper Networks, currently pursuing M.Tech in computer science from IIT Kanpur. I have more than 2 years of teaching experience, mentored more than 1,000 students. I have the expertise in computer science and data science subjects. And I secured All India rank 294 in GATE Computer Science, cleared ISRO and IC NELET exam, also got selected as Administrative Officer at AIC. And guys, those who are new to our channel, you can also join our doubt discussion Telegram group. So this is the QR code. You can scan this QR code and you will be able to join our MindMatrix official Telegram doubt discussion group where you can ask your doubts. Apart from that, we also post the PDFs of all our lectures that we are conducting on YouTube. Okay, so before starting, please like this video, share with your friends, those who are preparing for GATE. Also subscribe to our MindMatrix YouTube channel. So let's start, and this is the first question that we have from DBMS GATE CS 2023. Let's read the question first. Which one of the options given below refers to the degree or arity of a relation in a relational database system? So here it is talking about RDBMS, right? Relational Database Management System. And here it is basically asking about the degree of a relation. So we have a relation, like let's say for example, let me just give you some more clarity here. So let's say we have a relation named as student. So in RDBMS we have a table we called basically a relation is nothing but a table, right? And in that table, let's say we have the student ID or student number here, fine. And apart from that, we have a student name, right? And let's say student age also, fine. So this is a relation here and named as student, and we have these attributes, that is student number or student ID, the name and the age. These are the attributes, or we can say the column of a relation, right? And here we are going to have the records, okay, like this. So student ID is there, some name is there, and its age, the student's age is also present here. And these are the tuples. These are the tuples of the relation. Now basically this question is talking about the degree of a relation. So degree is nothing but the number of attributes or number of columns present in the relation schema. So here if you see, if I talk about this student relation table here, or relation basically, so here we have three attributes, so degree is going to be 3. Okay, so degree is nothing but the number of attributes of its relation schema. So option A is the correct answer for this question. Clear? We have number of, option B as number of tables stored, tuples stored. So we have 2 tuples here. Similarly, we have number of entries in the relation and number of distinct domains of its relation schema. So these are not relevant to the degree. Basically, degree is nothing but the number of attributes of its relation schema. So let's proceed to the next question now. I hope this one is clear to you. Now, second question. This is also very simple question from SQL. So this table is given to us, this relation is given to us, and here it is named as student. So following table named as student in relational database. The primary key of this table is roll num. So this is the primary key of this table. Okay, now the question says the SQL query below is executed on this database. So this is the SQL query that we are going to execute on this given table, and we have to find the number of rows returned by the query. This question is very simple SQL query is given to you. So here it is saying select star, that means you have to select everything from student table where gender is equal to F and marks is greater than 65. Gender is equal to F and marks is greater than 65. So here if you see, you have to select all the tuples, select star, all the attributes. So here gender is equal to F. We have gender F here, we have gender F here, and we have gender F here. So there are 3 rows where we have the gender as F, or we can say female. And other condition is marks has to be greater than 65. So here if you see, yes, this satisfies, 70 is greater than 65, this also satisfies the condition. What about this one? This is equal, not greater than, so this does not satisfy the condition given here in the where clause. So only 2 rows satisfies the condition, so we are going to get these 2 rows, these two tuples in the answer. So number of rows returned by the query will be 2. Answer is 2 here. Okay, very simple question. Now let's proceed to the next question from this DBMS 2023 question paper. And this is based on indexing, and this is a really good question, so carefully let's understand it first, right, and then we are going to solve it. So the question here is, consider a database of fixed length records stored as an ordered file. The database has 25,000 records, so total 25,000 records are present in the database, or we can say in the data file, with each record being 100 bytes. So record of, or we can say size of one record is equal to 100 bytes here, and total we have 25,000 records, of which the primary key occupies 15 bytes. Out of these 100 bytes of record, okay, 15 bytes consist of your primary key, and rest 85 bytes will be of basically we can say for other remaining data or whatever we have in the record, that consists of 85 bytes remaining, right? The data file is block aligned in that each data record is fully contained within a block. Now here this statement is very important, as it is saying that each data record is fully contained within a block. It's not like this. Let's say we have one block here, we have another block here, for example, and we are storing the records, and the remaining record, if this block gets full, the remaining record we are going to store in the next consecutive block. It's not like that, because this strategy is known as spanned file organization. Spanned, that means the record is spanning further into the next block. But here it is saying, carefully read, the data file is block aligned in such a way that each data record is fully contained within a block. That means every data record is fully contained in the block. It's not like some part of the record is contained in the next block. No, it's not like that. That means it is unspanned file organization. It is unspanned file organization. I hope this much is clear to you. Let's proceed further. The database is indexed by a primary index file. So here indexing that we are using, that is primary index, and we know primary index is basically sparse index. Okay, so we will be talking about that later on, which is also stored as block aligned order file. That is also in block aligned order file. The figure below depicts this indexing scheme. So here if you see the figure, so this is your index file, this is your complete index file, okay, and here you have the data file. Now carefully understand here, in the index file you have what? The primary key, you have the primary key, and you have the block pointer. So you have the block pointer which is pointing to a single block of a data file. Okay, so you have this. In the data file, primary key size is 15 bytes and remaining size other fields consist of 85 bytes. Clear? And in total you have 25,000 records. In total you have 25,000 records present in this data file. Okay, now let's come back to the question. Suppose the block size of the file system is 1024 bytes. So here it is saying that a block size is given to us is 1024 bytes for a single block of the file, right? And a pointer to a block occupies 5 bytes. So we have a block pointer, so this is of 5 bytes, we can say. Block pointer consists of 5 bytes. Now the system uses binary search on the index file to search for a record with the given key. So it is using binary search. basically on the index file it is applying the binary search as it is ordered file, so we can apply binary search, yes. And with a given key, that is your primary key, you may assume that a binary search on an index file of B blocks takes log of B block accesses in the worst case. Now this is also important. It is saying, let's say you have B index blocks in the index file. So here you have the index file. Let's say total number of blocks present in this index file is B, and you are applying binary search on that. So it will take, it is saying in the worst case it will take log B base 2 and seal of that. So block accesses, these many block accesses will be taken in the worst case when you are going to apply the binary search on the index file. See, if you are reading this question statement by statement and understanding the meaning of it, it will be really easy for you to solve these type of questions, okay? Then you won't commit any kind of mistake, okay? Now let's proceed further. Given a key, the number of block accesses required to identify the block in the data file that may contain a record with the key in the worst case. So basically it is saying you have to find the number of block accesses. So basically you have to find the number of blocks first in the index file. If you can find the number of blocks in the index file, just answer will be log of that number, right? Seal of log of that number will give you the number of block accesses. So we need to find the number of blocks in the index file. Now in order to find the number of blocks in the index file, first we need to talk about the records that we have in the data file. Now let's solve this question now. And now let's solve this question. So here, first of all, we have the number of records given to us, that is 25,000. Record size is given to us, which is 100 bytes. So first you need to write all the important information given in the question in order to solve it correctly. Now key size is also given to us, that is of 15 bytes, right? And then after that block pointer size is given. Block pointer size is given, which is 5 bytes. What else? If we talk about the disk block size, so disk block size is given to us, that is, here it is given, which is 1024 bytes. So we can write here 1024 bytes is the disk block size. And what about the index size? Index size is going to be the key size plus block pointer size. As you can see in this question, the size of one index will be the size of the primary key plus the block pointer size. So here it is 15 plus 5. So we can write here index size is 15 plus 5 bytes, that is 20 bytes. Clear? So this is the information that we have in the question. Now let's solve this one. So first of all, we need to find the blocking factor of the data file. First of all, we need to find the blocking factor of a data file. What is blocking factor? Blocking factor is nothing but number of records per block. Number of records per block. Let's say you have one single block here. You have, n number of records present in this block. You know the block size and you know the size of one record. So if you divide the entire block size by the record size, you will be getting the total number of records present here. Correct? That is your blocking factor of data file. So number of records is given to us, which is 25,000. Right? Sorry, number of records per block we need to find. So that is the block size. Block size divided by the record size. Now what is block size? So block size is given to us, that is 1024 bytes. Divide by the record size, which is 100 bytes. Right? So total number of records per block, and you have to take the floor of this. You have to take the floor of this, and what do you get? That is 10. Why we are taking the floor? Because it is unspanned file organization as given in the question. As you can read here, the database is indexed by the data file is block aligned in that each data record is fully contained within the block. So that is why it is unspanned. So total number of records per block we can find is 10 here. Okay, that means we have in single block we have 10 records present here, or we can talk about this in a single block we have 10 records present here. Okay, now we need to find the number of blocks required in data file. So now we are going to find total number of blocks. As of now we have evaluated the number of records per block, but now we note we have total 25,000 records in the data file. So we need to find the total number of blocks present in the data file. Correct? So number of blocks required in the data file would be what? That is going to be the number of records, total number of records divided by the blocking factor of data file, that is number of records per block, right? That is going to give you the number of total blocks required in the data file. So total number of records we have is 25,000 divided by number of records per block is nothing but 10, and you have to take the seal of it, because when we are talking about number of in terms of blocks we talk about, whenever we talk about number of blocks we have to take the seal of it. So you will be getting 2500 as the number of blocks required in the data file. Clear? That means in this entire data file you have now 2500 blocks. Clear? You have 2500 blocks to store these many records, 25,000 records. Clear? Now carefully understand, in case of primary indexing, as it is a sparse index. What is sparse index? For every block pointer is going to point to the first record of that block. Okay, similarly this pointer is pointing to the first record of that block. That means we don't have pointers pointing to every record of the block. No, it's not like that. That's why it is sparse indexing. And in case of sparse indexing, as you can clearly understand from this diagram, if I have 2500 blocks, that means 2500 indexes will be there. 2500 indexes will be there in this entire index file. Correct? Because every pointer is pointing to one block. So if we have these many blocks, that means these many indexes would be present in the index file, right? If I have the number of indexes, I can find the number of blocks present in the index file. Clear? So let's do that now. So here I can write, now we need to find the blocking factor of index file. Blocking factor of index file, and that is nothing but number of indexes, number of index per block. Like we have evaluated number of records per block, here we are going to find number of index per block. So number of index per block is nothing but what? The block size, because block size is same for the entire file system, that is 1024 bytes. So block size divided by the index size. So block size is what? That is 1024 bytes. Index size, that is 20 bytes, right? And you have to take the floor of it, as it is unspanned file organization. What do you get here? You will be getting 51 as the number of indexes per block. Now if we are saying this is the index block, so you have 51 indexes per block. Okay, so we have evaluated blocking factor of index file. So finally we can find the number of blocks required in index file. That's what we need to find mainly, because after that we can just apply the binary search, as it is an ordered file, right? So number of blocks required in index file. So here we can write, that is nothing but your number of indexes number of indexes divided by this blocking factor, which is number of index per block. That is going to give you number of blocks required in the index file. Number of indexes is nothing but the number of records in the data file, as I explained to the concept. So it is 2500 divided by this blocking factor, that is 51, and you have to take the seal of it. Clear? And what do you get? You will be getting 50 as the number of blocks required in the index file. Clear? Now now we can find now we have the number of blocks in the index file. So we have total number of blocks present here. So B value comes out to be 50 here. Now it is an ordered file, index file. We can apply binary search, and in worst case it is taking log B base 2 seal of it as the number of block accesses, how many blocks we are going to access that particular record. So we have total number of blocks as 50. So applying binary search, and we are going to get log 50 base 2 seal of it as the number of block accesses. So we can write also here, it is going to give me number of block accesses, how many blocks we have to access. So log 50 base 2 seal of it. So 2 raised to the power 5 is 32, 2 raised to the power 6 is 64. So we are going to get 6 as the number of block accesses in the worst case, and that is your answer. That is your answer. So here we can write 6 as the correct answer for this question. Clear? So this is your final answer. I hope it is clear. I explained you this question in lot of detail. I explained each and every point, why we are calculating and what we are calculating. So I hope this is quite clear to you, and try to solve this question by yourself also. Okay, so that's it from my side in this video. You can join our WhatsApp channel, and you can join our Telegram doubt discussion group, where you can ask your doubts, and you will be getting the PDF of all my lectures there, or that we are conducting on YouTube. Okay, also like this session, share with your friends, and subscribe to MindMatrix YouTube channel for more video updates and more lectures. Okay, so that's it from my side. Thank you everyone. Stay tuned. I will see you in the next video. Thank you. Bye bye.